Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, or add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, and please give us feedback. You can leave a review on iTunes to help other people find the show, send us a tweet or an email, leave us a message on Google+, or on our show notes, and you can also join our new community. Visit discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, and propose show ideas. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. I would also like to thank Hired, a job marketplace for developers and designers, for sponsoring this episode of Podcast.init. Use the link hired.com/podcastinit to double your signing bonus. Your host today is Tobias Macy, and today I'm interviewing Matthew Rocklin and Alexander Schepanovsky about their work on functional libraries for Python. So, could you guys please introduce yourselves? How about you go first, Alexander?
Hello everyone, my name is Alexander Schepanovsky, and I am a Python programmer. It's open source author and talks giver. Okay.
All right. And how about you, Matthew?
Hi, everyone. First, thanks for having me on the show. My name is Matthew Rocklin. I'm a full-time open source developer at Continuum Analytics. I usually develop in sort of the numeric Python stack, so all libraries that run on top of NumPy and Pandas. Previously, I did research in numerical methods and usability.
And
how did you each get introduced to Python? How about you go again, Alexander?
Yeah, we can see a difference between me and Matthew. So I came from web development and Matthew from numeric programming. And I think this will influence the rest of our podcast. So it was, I believe, 2007, and we were using Perl back then, and we were using our own kind of framework. And I decided that we need to move on, use some framework, some open source framework. And I looked around, and there were only old things in Perl. So I looked more around, and it was a choice at the time between Django and Ruby on Rails. Not really a choice even between languages, but between frameworks. And even though Ruby seemed more interesting, Rails seemed too dirty. Like the last thing was that they are passing all the local variables from this, what we call controller, to a template. And so I went with Django and was introduced to Python.
And how about you, Matthew? How did you find Python?
So I actually picked it up in graduate school. Previously, during coursework, previously I used C# for software engineering and MATLAB for more data analysis and science work. Particularly I used MATLAB because sort of had all the data science things for me, and also because my science collaborators, physicists, not computer scientists, could understand it. I sort of picked up Python just doing coursework, just as a fun side project. And I was sort of very happily surprised to learn that it could do both software engineering and it had the API that a data science user could use. So I could build tools and share them with my science collaborators. And that sort of combination really stuck with me. So that was sort of why I jumped into it, and I just haven't left since. To reiterate Alexander's point about the two different communities, I think it's a very valid point that people come into Python from a lot of different perspectives, and we have, we make different software, sometimes it doesn't work well together. And very recently, it's been very exciting actually to see the web community and the data science community start to come together. So, most scientists that I know now use Flask as sort of this like accessible thing. And a lot of the web developers I know are now using some of the more tools for visualization inside of the data science world. So again, it's very cool to see these two communities coming together. Although in some cases, like with the cases Alexander and I, we've you've duplicated some efforts.
This is not necessarily a bad thing.
Absolutely not. No, it's great.
And can you guys first explain what functional programming is and how it differs from the procedural or object-oriented programming that most Pythonistas are familiar with, and recognizing that functional programming is kind of an overloaded term with a lot of subcomponents, so feel free to delve into that as well.
I don't think you should oppose functional programming and procedural or object-oriented one. You should oppose functional programming and imperative. So in imperative programming, and the difference is in how you think about your program and how you decompose it. In imperative programming, you think of a program as an algorithm, which is a series of steps. So you decompose it into steps, which change the state of a world. And in functional programming, you think of a program as a function. So you have input and output and some with transformation from one to second. And you decompose it into a simpler function by using function composition and things like that. So in imperative programming, if you get some steps and you unite them, you get a procedural programming. And then if you add objects, you get object-oriented programming. But these are like add-ons on imperative programming. And in functional programming, it's usually associated with things like pure functions, monads, and higher order functions, and things like that. But these are only the consequences of a way of thinking about a program and a way of decomposing it. Because when you start to decompose your big function into smaller functions, you start to see that not functions are equally easy to decompose to. So it's easier to decompose to pure functions and things like that. And you want to make to give special attention to side effects and probably separate side effects from the rest of calculation. And so all these things that are usually associated with functional programming are just consequences of the idea of functional programming. So this is my understanding.
Yeah, so I think that's a great definition. I think that many developers will have different understanding of this term. I think a Haskell developer and a Clojure developer will think about what functional programming is a little bit differently. But I think the definition provided by Alexander is great. How I would define it actually is more of a historical definition. I would say that functional programming is a set of language features that come from languages that descend from two root languages. Lisp, that originated around the same time as Fortran and Algol, and ML, sort of an academic language to prove theorems about type systems that originated in the 1970s. Lisp begat languages like Common Lisp and Clojure, and ML begat languages like Haskell. And I would say that these languages have a lot of language features, as all languages do, and the language features that appeared only in these languages, but not in the sort of C and Fortran-like languages that we're more familiar with, all of those features sort of tend to be called functional. So this might be function composition, functions as data, higher order functions, but also things like macros or algebraic type systems, sort of more fancy things, or more pedestrian things like streaming iterators and a strong reliance on core data structures. Today, I would say that people often use the term functional programming just as a reaction to highly imperative or object-oriented programming. There's sort of this push towards simplicity. So when I read blog posts, I get a variety of terms that all seem to be lumped into this term of functional programming. And if it's a Haskell programmer, it might be talking about algebraic type systems. If it's a Clojure programmer, it might be talking about macros. And so there's a large grab bag of concepts here.
And how did you each get started with functional programming?
For me, it's not like you don't start with functional programming at first because you don't know what functional programming is. But you start thinking in a functional way sometimes. And you probably got introduced to some concept like pure function or higher order functions. And you can see a practical advantage of, for example, higher order functions because you can write functions which are more customizable this way. And it could be easier when writing objects. You have less parts or less code. And like this, you get introduced to these concepts, and not only concepts, but the specifics, the application. Then I also got introduced to Common Lisp. I never actually used it for anything practical, but it was just played with it and extracted some ideas from it. So this is my story with functional programming. I later took a look into ML and Haskell, and I don't think they're that much practical, especially Haskell. It has too much hassle in it.
I think there are a lot of Haskell developers that would disagree with that, but I also agree with you.
Yeah, even if you have less code, it not always means you spend less time writing it, and anybody else will spend less time reading it and understanding it or modifying this code. And there are huge amount of hassle with many things in Haskell, like I/O. Okay.
Matthew, how'd you get involved in functional programming?
So I think, like Alexander, I probably started learning functional concepts before I really identified them as being functional concepts. I think that was a really great point. When I sort of intentionally started learning functional programming, it was actually a social activity. A couple of my friends, Avi Newman, John Jacobson, and I wanted to get together and drink some beers. We wanted some activity to do. And so we decided to implement the same problem. It was like a job interview problem in a variety of languages. So we did it in C and in Fortran and in Clojure and in Haskell and in languages like Mod. And it was actually really interesting to see what about our solutions was intrinsic to the problem that would stay the same across all these languages, and what about our solutions was sort of a side effect of the language. And it was just a really fascinating experience. I highly recommend grabbing a couple of programming friends and doing the same thing, especially if they're in different disciplines. Neither Avi, John, or I had a common background. John Jacobson in particular was quite keen on Clojure, and he sort of brought us in that direction. And as a result, I sort of screwed on the Clojure for the following year, and that had a really strong impact on my programming style, even today. I don't think I've ever used functional programming I've never used a strictly functional language in practice, but I took a lot of the ideas that I learned from delving into functional programming into my everyday Python code. And I think there's really a lot of value to functional programming, even if you're not doing it explicitly, or if you're not, in Haskell or in Clojure, you can still use a lot of the concepts in everyday style.
And we've touched on it a bit, but what are some of the benefits of functional programming, and when might somebody want to use functional paradigms in their projects? I
may first add a small remark on writing the same thing in different languages. There is a resource called Rosetta Code. It's a wiki with a solution in different languages for different problems. Could be quite interesting to look sometimes. And about the benefits on functional programming. For me, it's like you can use this customization with which higher order functions give you without the unneeded layer of like classes and factories and things like that. You can achieve it in object-oriented paradigm, but it's usually more hassle. Then also, if you think not about concrete specific features, but about thinking, it could also be beneficial, because the alternative is usually imperative programming, where you think of steps. And in functional programming, you think of operations, and you think of data, and you think of operations which you apply to it. And it could be a higher level of thinking. So you might compress bigger algorithm to fit into your mind. This is probably the highest benefits, but different features could also be beneficial.
Yeah, so I totally agree with functional programming lets you decompose a problem into functions that are pure and have clean inputs and outputs, and how we can solve most problems using just simple data structures and functions that call each other and have very dependable inputs and outputs. I generally classify this under the concept of modularity. And I would say that if we had a more object-oriented person on the phone, they might also say that object-oriented programming also enables modularity. It also enables people to break down large problems into small problems. I think the difference comes in the style in which one achieves that. So I think that functional programming, there's maybe a tenet that you don't need an object, which is this marriage of state and functions, and that often state and functions can live separately, and that's often sufficient. So I think you can actually solve a large number of problems, very hard problems, using just core data structures like lists and dictionaries and strings and numbers, and simple functions. I think a lot of functional programming, a lot of the resurgence recently has come out of sort of a backlash or a reaction to the sort of heavy object-oriented programming that came out of the 90s. Would you agree? What are your thoughts, Alexander?
I can add to it that when you model your domain in object-oriented way, usually create with types which represent some data. And when this is always a new classes, new types, so you need to implement lots of operations to handle them.
Right.
But if you model your data with some data structures like dicts, lists, and so on, you already have lots of operation in language for them. So usually it's less code and it's faster to model things.
Yeah, and in addition, not only is your code simpler, but your code can more easily interact with other code that you didn't anticipate. For example, if I just use dictionaries and lists, I can use the JSON library immediately, trivially, without having to think about writing a toJSON method. I think Rich Hickey has a good example here of the HTTP request object in most languages. There's usually some object that has lots of sub-objects, and if you want to interact with an HTTP request object, you sort of need to have the documents side by side as you're walking through this object. While instead it could just be a nested dictionary. And then I could pull requests off of some socket. I could dump them into a document store like MongoDB, or I could serialize and put them to disk, all without having to write any extra code to handle those interfaces. So I think one major feature of functional programming is just a reliance on shared abstractions that are common to the language, core data structures. But I think that there are also some other features that are also associated to functional languages that are still also valuable. Like algebraic types are something that came out of ML and help compilers ensure correctness and improve speed. And these, might be sort of strange if you're looking at it from Haskell, but if like a newer language like Julia, it's very accessible, and they've used algebraic types very effectively to improve performance. Something like macros, which came out of Lisp, can help library developers make more powerful user APIs. And this is something that's been very helpful in, say, the language R, which uses them to make very powerful user APIs, even if they're a little bit strange for developers. Immutability is something that's often referred to as a functional concept, and software transactional memory. And they really help with concurrency. And there's lots of immutable data structures inside of Python or inside of external libraries within Python. And software transactional memory has recently been added to PyPy. So there's lots of ideas that come from these languages that are still useful in a variety of different contexts.
Yeah, and we have progress in things like that, and I can see little progress in object-oriented programming.
You may have alluded to it a bit earlier, but what is it about functional programming that people find so intimidating, and what do you think has led to its recent rise in popularity?
So intimidating? It's not that much intimidating if you don't tell people this is functional. And you don't need to. If I go a bit aside,
sure.
When you market like a functional programming support library for a language, you could say like, so stop doing like that and write code this way and use my library. And this is a very weak proposition. Or you can have some utils which actually solve problems that people have, like some utils to work with sequences and utils to work with collections and like that. And when you say my utils, they are very customizable because they accept functions. So they are high-order functions which accept functions. So you can use them for many tasks with your sequences or collections. And this way you're solving some problems people already have. And this way people can Google your library and Google it by Googling their problems, not Googling functional programming in Python, which I think far less people do. And when people start using these utilities for sequences and collections, they start thinking of how were formed these utilities, which are high order functions. And they start to look around in your library and maybe introduce to other concepts like function composition. So it should not be really intimidating. And so back to why is it? Besides its name, I think anything that's not people not used to could be intimidating. Also, we have this thing that you can pack lots of things on single line, and sometimes people abuse it, and this makes the code unreadable, especially for people who are not used to things like that. This could be intimidating. Also, some features like monads could be intimidating because it's really hard to explain why do you need those, because you don't need those in most languages. And so this is my take. Maybe Matthew can add more.
Yeah, no, I totally agree with the right way to brand functional programming, and how the conversation isn't functional or not functional. It's here's good ways to write software and less good ways to write software, and that's really where we should be focusing if we want to have if we want to be pragmatic, if we want to have a positive effect. I would say that I think everyone learned some derivative of C historically, and so if you knew a functional language, it was usually your second language, and as a result, it felt a little bit fringe or elite. And this impression of it being elite, I think, was very damaging to the ideas within functional programming. I mean, I think even within the core Python community, there's still a little bit of hesitancy about any concept that's called functional because of this bad history. But in truth, I think a lot of the concepts of functional programming are actually much simpler than people think. For example, I think that macros, which are maybe a little bit strange to people, are simpler intrinsically than, say, class inheritance in object-oriented programming. However, I say recently, so you asked about the recent rise in popularity, and I would say that recently there's been some hardware changes, like multi-core architectures have brought on parallel computing, and there's been a lot of need around highly concurrent systems. And for these, the fully stateful model of imperative programming and mutation and state and object-oriented aren't particularly ideal. And so sort of the functional language community was sort of off in the side, this very small minority saying, hey, we've actually got all of these nice tools that are really well suited to handle parallelism and concurrency and the building of large systems. And that utility, that pragmatism, really helped to reverse public opinion. And so I think there's now maybe sort of a revitalization of functional thinking to the point where most modern languages coming out now include a decently large subset of functional concepts within them. And this really makes those concepts much more accessible to single language developers. The fact that in Python you can use functions as data, or you can use higher order functions, and that's accessible to someone who's just learning programming is really powerful, I think.
Yeah, and I think, too, that part of it might be attributable to the recent rise in popularity of JavaScript, because, while it does have some object-oriented capabilities, it's generally used more in a functional aspect of passing functions around as variables and as data. And also, there's a new generation of developers coming up, and as you said, a number of developers started with some variant of the C programming language, and therefore a lot of the functional principles are a little bit more foreign. But given that there has been a slight rise in the popularity of functional languages, like you said, because of the recent changes in CPU architectures, then the newer programmers who are getting started don't necessarily have that same shared history and are a little bit more willing to experiment. And also going back a little bit to what you were saying about functional paradigms being not as widely advertised or encouraged in Python. One thing that I've seen in a number of places, both in some of the official documentation and also in some company style guides, is, for instance, avoiding the use of the map, filter, and reduce functions in favor of list or dictionary comprehensions. And one thing that it seems that in some respects that might be a disservice, because I haven't tried it specifically, but it seems to me that the comprehensions wouldn't necessarily be as composable as some of the map and reduce functionality that are more intended to be more intended to be used in a functional approach.
I'm actually totally fine making map and filter a little bit forbidden. The way I think of it, I think I'm going to steal some ideas that Alexander has spoken about, but think of all the ways that you use a for loop. Right, you might use a for loop to apply some function onto some list, or you might use a for loop to filter some list by some predicate, or you might use a for loop to reduce some list to some single number, like a sum. And if you're familiar with map and filter, you realize that 70% of your use cases of for loops fall into the cases of map, filter, or reduce. And so I think that map and filter are strictly better than a for loop, but the core language designers recognized this, and they elevated these common patterns to syntax, to the level of syntax. They elevate it to the list comprehension. And when you get up to that level, that's even one step better than map and filter. I think that if list comprehensions didn't exist, map and filter would be very, very useful. But because list comprehensions do exist, they're not so much necessary. I think what libraries like Funky and tools both provide is they provide a bunch of other functions like map and filter that do the same sorts of things. They represent common patterns that people use, but that haven't yet been elevated to the level of syntax. So I would say, yes, don't use map and filter, use list comprehensions. They're usually more readable, but map and filter have cousins, and maybe it's good to look at those cousins.
I think both map, filter, and comprehensions are fine. The usual reason to limit use of some functions or some language constructs is to make your code base more simple, like less features in it. Mm-hmm. So it could lead to less errors if you have this code style. But for me, both is fine. Regarding when you go from map and filter, which are special purpose to with lists or other comprehensions, they are more general purpose. So this is a try to go from some specific solutions to DSL. And they have overlaps in what we provide. But I think you still have usage for filter and for map.
Yeah, I really like that idea, actually. Map and filter are good at giving a name to a common pattern. And so even if you use list comprehensions or use for loops, it's nice to have that name. Oh, I'm doing a map now. And map and filter, as you say, are more explicit than our list comprehension.
Sometimes you can also use a partial of map and or filter, but this doesn't work with comprehensions.
Right, and that's part of what I was thinking of in terms of the composability, where map and filter are a little bit superior in that respect. But like you said, Matthew, in a lot of cases, the comprehensions can be more immediately readable and clear as to what they're trying to do. But also there are cases where you can get a little carried away using comprehensions where, for instance, you're trying to do 2 or 3 different levels of filtering within one comprehension, and then it might make more sense to either compose those comprehensions together and nest them a bit, or to actually take advantage of the explicit filter call, as Alexander was describing.
I actually think comprehension language could be expanded. Like the most thing I miss is let in comprehensions. Yeah, when you assign something and then use it later in if or...
That would be very helpful, I agree.
Yeah, because now sometimes you need to just duplicate an expression. For example, in if and in an expression itself before the for. And in a common Lisp, for example, they have a very, very complicated loop macro, which, yeah, you heard about it. And it does not look like the rest of the language, but it is causes contradictions. So some people hate it, but for many people it's very handy because you can make lots of things with it, and you can do map and filter and aggregations and do several things at once. And in Python, you sometimes need to fall back to command for, because if you want to do several things at once, then it's usually the most efficient and sometimes the only way.
And so we've done a pretty good coverage of list comprehensions. What other aspects of the Python language lend themselves to being used in a functional manner, and where do they start to fall down?
Maybe the most noticeable is the absence of special immutable data structures. But you can usually be okay with like immutable by convention, which is not very efficient but works, and you can mess it up also. but still.
Yeah, so I would say that Python actually has a pretty good functional core. I think ideas like streaming iterators, functions as data, functions as first-class objects, really good core data structures. There's the legacy things like lambda, map, and filter, but higher-order functions generally. These are all functional ideas that are really common in Python, and that Python programmers do a very good job of using in common style. So to a large extent, Python is a functional language. There are some things that Python doesn't do, like, as Alexander was saying, immutable data structures. Well, there's actually been some good work in this. I think fn.py has some persistent data structures with structural sharing. Kurt Smith has a project called Ozymandias, where he's implementing persistent data structures at the C level, actually using Python, and they're very efficient. It's still work in progress, but it's a fun project. Some things that I would love to see is better type systems, and there seems to be some push on this in Python 3.5. Those are the type modules coming out, not doing anything yet, but it's still present. And macros. I'd actually really love to see macros. As someone who builds user APIs, I would love to see macros.
There's actually a Python library that I came across recently where that does provide some macro capabilities. I'll see if I can find the link and I'll put it in the show notes.
Yeah. There are actually a couple of good ones. There's MacroPy, and there's also Code Transformer by Scott Sanderson and Joe Devnick at Quantopian. These both do really cool things. They're manipulating the bytecodes. They're doing lots of cool things. Nothing will ever work without core language functionality in the interpreter. Most of my users are actually using the Python interpreter, or like IPython or the Jupyter Notebook, and it's really hard to provide macros without some kind of import hook or some kind of decorator.
Yeah. There's also, I don't know if you're familiar with it, but the High Laying project, which is
neat.
Yes, we had them on in a previous episode, and anyway, the project creator was describing how he was able to backport some of the Python 3 capabilities to Python 2 using macros that it was the yield from operator that he backported from Python 3 using a high macro. But yes, like you said, it does require some level of import to be able to inject that into the interpreter.
I also have a point on macros, and it's a contradictory one, because it's very fascinating to have this opportunity to extend the language. But this is a very dangerous one. If you add your macros to a language, you get this danger of degenerating into this language into some dialects. So some people will start using some macros and other people other ones, and when they don't just understand each other, they can't read each other's code. It happens more with smaller languages like Scheme, when you have a small language and when you guys can build on it with macros. But for languages like Python, it could also be dangerous. The other alternative is that you don't use much macros. like you have them, but you should be very cautious about using them. And I think in Common Lisp and in Clojure we're a bit adopting it.
Yeah, I think that's a totally valid point. And macros are definitely a language feature that can destroy a language because it provides too much power to library developers to separate themselves into their own domain-specific language. And along with macros, you must include some sort of community standard that you should never use a macro unless absolutely necessary. I think if you look at, again, languages like Clojure or Julia, this has become the norm. Very few people use macros. It's considered to be a faux pas. So yeah, and also you could also say that Python provides lots of opportunities for us to segment ourselves. There's lots of very say too powerful ideas in Python like metaclasses that enable this sort of bad behavior already.
And monkey patching.
And monkey patching, yeah. Where Python's very permissive in lots of ways. There's a way it's not permissive, but as a library writer who serves scientific user communities, it's something I look at R, I look at Julia, and I just really want the ability to write macros because there's certain APIs that users love that are just impossible to write without language support for macros. But I agree, I only want sort of 10 people in the world to be able to write Python macros. Everyone else, not allowed.
And so, can you each describe what your respective libraries provide in terms of functional capabilities and what their particular focuses are? And also wondering if they're distinct enough from each other that it would make sense to use them both in a single project.
The most obvious thing that Fancy provides is sequences and collections utilities. And this is the thing people use the most. Because you don't need to get functional programming and stuff to use it. I already talked a bit about it. Then Fancy has some extension on functools, I guess, with patels, write patels, carrying, and composition, and some other things. And then there are just some utilities for lots of things, like string utilities. One example is that I always hated how you need to in Python first match a thing with a regular expression and then write if it matched, then go with it's like you always need at least 3 lines of code to use a regular expression. And before Python, I wrote Perl a lot, and it's much easier there. And usually it's 1 line. So I added some things to work with regular expressions. Then some flow control utilities and some primitives, and ironically even some utilities for you to use with objects like cached property. We now also have this cached property in Django, I believe from 1.6, and this is really handy when you have these objects like ORM objects, and you need some properties that shouldn't be calculated twice for an instance. And then there is debugging utilities for functional programming, because when you debug a functional program, you sometimes can't go the way you usually do. You can't add print because everything is happening on a single line, or you can't use watches and stepping because there are far less named variables. You just pass everything to one function to other function and like that. So it has some debugging utilities like decorators, logging and printing and timing and things like that.
Yeah, so PyTools, that's TOLZ, is a collection of functions that are good for managing iterators and functions and dictionaries. These functions are pure, composable, lazy, and tuned. And they sort of follow the standard functions you'll find in a variety of languages. So if you look at languages like Clojure or Scala, or in JavaScript, libraries like underscore or Lodash, or a variety of other languages in Ruby and whatnot, you'll find that there's a bunch of functions that work on iterators, things like map and filter, but there's far more, like group by and sliding window and repeat and memoize and curry. And you'll find these functions all over the place, and they end up being really useful when you build an ecosystem based on core data structures. So earlier in the show, we were talking about the value of just dealing with lists and dictionaries and iterators and normal functions, and how this is really good for an ecosystem. And once you start to use only these core data structures, you find there's actually a lot of functions you often want. And they're just not in the Python standard library, but they are in lots of other standard libraries. And so a lot of other languages have sort of converged to this common function set, and tools was just the instantiation of that common function set in Python. You asked about how these libraries might relate to each other if they're different, whatever, use both in the same project. I think that they probably overlap enough that it's not usually necessary to use them in the same project. They're also both simple enough that you could. They're both very lightweight dependencies. I would say that tools is notable compared to all the other functional libraries in that it's very low tech. It's usually just functions. And it's also, so it's very accessible. You shouldn't ever need to learn some new concept. The same with Funcy. It's also notable in its performance. Tools has been heavily benchmarked, largely thanks to Eric Welch, who does most maintenance today. And Eric also rewrote PyTools in Python, which makes all the iterator stuff about as fast as you'd find in a compiled language like Java on dynamic data structures. So tools is intended to be sort of very much like what you expect if you're familiar with other languages, and it's very fast.
The one thing that one obvious difference is that you use the iterator versions of all the functions. But
that's true.
Yeah, the Fancy is a bit different. First it has two versions for many functions, like a list version and iterator version. And they are named differently for Python 2 and for Python 3. In Python 2, it's like if it starts with I, then it's iterator version, like map and IMAP. And for Python 3, it's like map and LMAP. So in Python 3, by default, you don't have a list version of map and filter and like that. And I don't really like this change, because this is so confusing for many people. You like call this map or filter, and it does not actually do the job. You pass this iterator, and then later you can get something from it. And you can forget that it's iterator. You can try to add it to a list, or you can try to iterate it twice, which gives you an error in a different point when you actually get this error, when you actually made it. So I don't think the iterator should go by default. For me, it's more like an optimization. So the Python 2 way of doing things makes more sense to me.
Right. So this is actually this difference. So you're right. So everything in tools where possible is an iterator, even in Python 2. So if you import map from tools in Python 2, you'll get the equivalent of itertools IMAP. And this is by design for two reasons. One, tools is one of the desires here is that tools should be minimally creative. We didn't want to design an API or make those decisions. The core Python language is going lazy. We decided to go lazy too. And second, this also probably comes down to are backgrounds. In web programming, I suspect that many times you want map, you actually have a small data set, and you want that to be a list in memory. Where for me, I do a lot of data processing, and for me, it's very valuable to have everything be lazy by default. I can stream through tens of gigabytes from disk on my machine and be very happy, and tools just works in a small space. But that I agree with you that in many cases, when I do work on just very small lists of 5 elements, I really do find writing list map sequence to be very annoying all the time.
Still, I see this using iterators as an optimization, so it should not go by default. And this way, I don't agree how Python free map and filter does things. And, so you should go with lists by default, and if it's too slow or too memory consuming, then you switch to iterators. It's like premature optimization. And Python 3 forces you into it. And iterators, they are inherently more complex than lists. They're more hard to handle. So you write a more harder to handle code by default. And this is wrong.
It's also very useful sometimes, though. I think if the whole community gets on board with the concept of lazy iterators, then the whole ecosystem is lazy by default, and that has a lot of value. Again, when you're processing data, which for me is the common case. Again, I think this is a difference between the web community and the science community, where it might be an optimization, but it's an optimization we want almost all the time, and it is quite tricky to make sure that all the libraries you're using everywhere are being lazy by default. It's sort of very easy in your own code just to use lists, but if you're writing infrastructural code that's going to be used by many different projects at the same time, you sort of want to be lazy by default, because a lot of those users, again, in my community, want the laziness. It's of high value. But we can disagree. That's fine.
And so, what inspired each of you to create your libraries?
I started from writing some data utilities and function utilities. It was a part of a web application. Only later I extracted. It just grew this part over time, and then I extracted it into a library, and it was obviously very limited in its scope, because I only added the things that I needed for a project. So it's not like a complete library. So I looked at Clojure standard library, Core library, and on _JS library. And I looked carefully what things could be useful in Python, and if I need to change them when I'm moving them to Python. And I implemented all functions from Clojure Core library and from _JS library, which made sense to move. And so Fancy was born. Later I added some features that I needed myself, or some features that people asked and or contributed. The idea of a library also is that it aims to limit its scope at some point. So like you add to it, but at some point it's complete. Nowadays we usually most projects and libraries were never complete. You go with newer versions and you add features, but I don't think it's a good idea for a library like this. You need to limit scope at some point and say that this is out of scope, like immutable structures, out of Fancy scope definitely, and some other things, and stop at some point. So, Matthew?
Yeah, so my experience was very similar. I was writing a lot of Clojure at the time, and I found that what I really liked about the language wasn't any of the fancier features. I just really liked that the whole ecosystem was based on everyone using core data structures. And then again, I talked about, HTTP requests were just a nested dict. Database connections just took in dictionaries of iterators of dictionaries. And this I found to be really valuable. And so I took that same thinking into Python, but I found that a lot of the functions that I was used to using weren't present. And so I looked at Clojure, I looked at underscore, I looked at Ruby's enumerable, and I just started implementing them in tools. And I found that, it's a really nice approach to use core data structures. And if you have a good set of functions, 20 or so functions, that actually encompasses 90% of what you want to do on those data structures for most programs. And so I was able to lift up my thinking out of for loops, out of maps, to more higher level concepts. It was really interesting looking at all these different languages and the set of names that they had converged to, the set of functions. And so it was actually really an easy project to build. All the API was set out. So at the time, right after building this, I started working on a few different projects. It was actually the same algorithm, but in different languages. And it was really cool to use Python underscore and Clojure and have sort of a lingua franca, a common language among all of these different languages where I sort of depend on this API being present. I found that really valuable. To go with Alexander's point, I think that the scope of these libraries should be small. Most pull requests a day I reject just because they're a little bit weird. I don't think they should stop. I think they should keep growing. I think we're going to keep learning. But I think both Tools and Funcy have done a very good job of limiting their scope and of being correct. There are almost no bug fixes. It's actually really cool. And they just work, and everyone understands and trusts everything in the libraries.
The reason is that the implementation of most of functions is very easy, very simple.
Yeah.
Sometimes it's more complex because you optimize it, but it's still usually very simple. The most value is in concepts and ideas.
Yeah. So I think that it's very simple also because they're communicating off of very simple shared abstraction. They communicate off of lists or iterators or dicts. So usually bugs occur in software because we have two things that are independently correct, but when they interact, there's some complex behavior and a bug arises. And so usually a lot of bugs are tracking down, this piece didn't interact well with this widget. And all of the functions in Tools and all the functions in Funcy are completely isolated. And we just trust the underlying Python mechanisms, iterators, dictionaries, etc., to be the shared substrate along which they communicate. Which again, that lack of interaction really makes developing these libraries a pleasure.
And for anybody who isn't aware of it anyway, there's a functools module in the Python standard library that provides some methods that enable some functional paradigms. I'm wondering where that module falls short and how your respective libraries either augment or replace some of the functionality found therein.
First, functools is not like a library with an idea. It's like storage for very loosely connected things which get added into Python over time. A more interesting one is itertools, which actually has some structure and has some utilities to work with sequences, which are probably more popular and more known. If you speak about functools, when, for example, it lacks even compose, function composition, probably very basic thing, so it's very easy.
Yeah. I'll agree with Alexander here that I'm looking through the functools API right now, and the things that I reasonably use are LRU cache in Python 3, partial, single dispatch, and reduce, because it's been sort of evicted from the core language. And there's really not a whole lot there otherwise. Things like composition, pipe, curry aren't present. And these are sort of like standard things you'd expect to be in any functional library. So it's not really that. It's clearly not sort of the love of the core developers. I'd also say, so I think functools and itertools have a lot of really great functionality in them, but sometimes, so as someone who tries to adhere to standards met by other communities, sometimes they deviate a little bit from from common interfaces. So, for example, the group by function in itertools is not like the group by function in any other language. It's a false cognate. I think the LRU cache in functools, I would much rather have seen them accept some mutable mapping as an input rather than bake in LRU to the caching mechanism. There are just some ideas that I think it would have been better if the community had looked out to what other languages have been doing for these exact same concepts and taken a little bit more inspiration. That being said, I think it's also fine. I think that a lot of this code shouldn't be in the standard library. It should be in third-party libraries. Packaging is good enough now that func or tools or funpy can just be the standard functional programming library for Python. It doesn't really need to be baked in.
Yeah, that was one thing I was going to ask about, is whether you thought it would be useful or something that you would consider pushing for to try and get some or all of, or at least some small portions of some of these other functional languages baked into the standard library to either augment or replace the existing functools. But I also know that there's a common meme that the standard library is where modules go to die because it's a much slower rate of change and it's not as easy to introduce updates or modifications to those modules once they do become part of the standard lib.
I think now that we have better packaging tools, they're still imperfect, but they're better. It makes less sense to keep a big standard library. So we have obvious things like requests, which is far better than built-in urllib and urllib2 or even slightly fixed urllib in Python 3. But still we don't have this request in standard library, and I think it's okay. The main reason is this better packaging tools. And this situation permits each project to develop separately and usually faster. We can see how even better packaging tools like in Node.js community, they lead to lots of packages, and they lead to smaller packages. So the better your packaging tools, the more and the smaller packages you have, and they develop the faster way. We don't need to keep everything in standard library at this stage.
Yeah, I agree. I think the only value that it would serve, I think, is a value of social proofing. That, okay, here's something that an external authority has sort of declared as good. But I think we've handled social proofing through things like GitHub stars. Both func and tools are well downloaded. They have lots of stars. We both publish continuous integration tests, and that's sort of enough to convince people that they're worth doing. The other value would be with distribution. But I think, at least in the scientific world, sort of the Anaconda distribution, and I'm grain of salt, I work for this company, but the Anaconda distribution has become sort of a de facto standard among numeric developers, and requests is there. All of the libraries that you sort of think of as being standard are distributed along with what people download when they install Python, and you can trust that it will be on the user's machine.
You guys have mentioned it a couple of times, the fn.py library, and I'm wondering if you guys can compare and contrast that with your own work, or if it makes sense to dig into that further. If you don't think it makes sense to dig into that further, then I'm happy moving on to the next question.
I looked at it and I read code of it, and it's an interesting library, but I think of it more like a research project, not some practical tool. It's a bit like Haskell, and it has many interesting things in it, and this is why I read its code. But I never even tried to use it in any real code.
I think that fn.py is a really cool project. It has actually a lot of really cool stuff in it, like persistent data structures, a lot of neat syntax tricks to make pretty lambdas and streams. There's sort of very clearly some heavy sort of Scala or Haskell influence in it. I would say that it differs from the two projects we've written, and that its scope is much, much larger. So it's encompassing lots of fun ideas inside functional programming, where func and tools are both sort of restricting themselves to what is clearly pragmatic, clearly Pythonic, and you can sort of insert into a workplace without trumpeting the sort of functional programming idea. But I think that for the conversation, we should probably have Alexei here, and that's not present.
And so there are a number of concepts involved in functional programming, such as currying, function composition, immutable data, and pure functions. And we've covered a number of those, but for any of them that we didn't cover, can you describe some of those concepts and explain any that you tried to incorporate into your libraries if we haven't already covered them?
I tried to incorporate some practical and useful tools, and still I have things like function composition, and I have even helpers for immutable data to use common collections like dicts as immutable by convention collections, which I a bit doubt is useful, but still. So my approach is not like adding more concepts in the library. I don't think I have much more than those. When currying, composition, maybe partials, a bit immutable data helpers. That's it.
So I'll say a few things. So like Alexander, tools has sort of the basic pure things, pure functions, core data structures, function composition, iterators. But some of the concepts we haven't talked about are present not in our libraries, but in other libraries that are accessible in the Python ecosystem. So I'll talk about those for a moment. There's things like dispatch. There's single dispatch and functools. There's a library called multiple dispatch that I also wrote that does allows you to dispatch a function based on all the types of all the arguments, which can be handy to write some generic functions. There's things like macros. So a macro is something like a function which gets its full input unevaluated. So for example, if I call a function f on the input 1 plus 2, the function doesn't get 1 plus 2, it gets the evaluated result 3. So when I go into the function call f, I get the value 3, and f can work on 3. Macros actually give the unevaluated result 1 plus 2 as like an abstract syntax tree to the function. And this can be useful if you want to say make a nice plot function. You want the user to say, plot x equals y squared. And you actually want to have that full expression being handed to the macro without being evaluated ahead of time. Sort of the common use case here is the assert statement in Python. So with assert, we say assert x equals y, and assert gets true or false. And if it's true, then it does nothing. If it's false, it raises an error. But if it's false and it raises an error, we actually want to give a good error message to the user, and we want to say x x, which happens to have the value 3, doesn't equal y, which happens to have the value 7. And we've sort of gotten around this in very hacky ways. If you look at the project PyTest actually compiles your code a little bit to do this for you. There's a really cool project called Code Transformer by Joe Jevnick and Scott Sanderson that does a lot of sort of compilation of Python functions in a really cool way. I'd never use it pragmatically, but it's very neat. It's worth looking at. There's things like immutable data structures with persistence and structural sharing. This is another concept. So if I have say some data structure like a dict, and I want to change some element of it, but I've already handed that dict off to some other process running some other thread or some other coroutine. I want to make sure that that other user of that data doesn't see my change result. So in Python currently, I would have to make a copy. This is what Alexander was talking about, immutable by convention. But if it's possible with sort of very fancy underlying data structures to make a slight copy of a data structure like a dict or a list that even though logically they're completely separate, these two copies, one slightly changed, in memory they actually share a lot of the same structure. So this is persistent data structures with structural sharing. There's a project by Kurt Smith called Ozymandias, which is sort of new and rocky, but it does this on the C level, so it's quite fast. There's general thinking about types, and there's again some nice work from the core language team to think about adding function annotations into Python 3. There's a whole types module, allows you to spell interesting types. So some interesting work happening there as well. So just to be clear, there's lots of functional programming happening in Python, and what Alexander and I have done is just sort of a small part of it. There's lots of other libraries to look at.
Maybe not a concept, but another touch on functional programming thing that you can do in Python is like utilities to abstract away flow control. And in Fancy I have some of those, some for handling errors and some for like making retries or things like that. I also have some backports from Python 3. Like in Python 3.4, we have this suppress context manager. Like we've suppressed some exception and a block which ignores this exception. You can write it in Python too also, and so I backpose and edit a few other things like this to fancy. And about immutable data, it's like if you have them by default, like in Clojure, in where all your collections are by default immutable and they share structure. This is a very different thing when you have these immutable collections as a separate library, because in this situation, when we're separate library, it's a very special purpose tool which a very small amount of people will use. And I think in Python it will be like that.
That's true, but I would suggest that as long as we adhere to some of the interfaces, like mutable mapping or immutable mapping, we can pass these things around and get some more coverage. So for example, I think that Python has actually done a really good job about having some shared interfaces like the file interface, the _iter interface. In the scientific world, we've got the array interface. And these allow a lot of more custom applications. So many people have written array libraries, and they can all interoperate because they all use these shared protocols. And so I think that with things like immutable data structures, the sort of hook into the general ecosystem is going to be with those shared protocols. They're going to implement mutable mapping. They're going to implement sequence.
I agree. These protocols in Python were very beneficial. We were recently this big thing in Clojure called transducers. And when people started to make their own transducers in all sorts of languages, and this includes Python. So there are probably several implementations of that for Python. And then if you look a bit closer to it, it does not actually make much sense for Python, because transducers for Clojure, they solve the problem that Python had solved years ago with iterator protocol and with things like that. So protocols like iterator protocols and abstract base classes like sequence, they help a lot, I agree.
And so what are some of the resources that you guys have found to be most helpful when trying to learn and apply different functional paradigms to your programs?
I'm in a way self-taught programmer, so I just try things. But there are probably this talk by Rich Hickey called Simple Made Easy, which advocates using data instead of classes and generally simpler things, like things with less amount of paths. Not sure if you heard it, but you probably should.
I've heard of it a few times, but I haven't yet watched it, so I'll definitely take some time to do that.
Yeah, it's only half an hour and it's really good. Rich Hickey has other good talks, and many of them are very, very opinionated. Like he advocates things that he does in Clojure. And for many languages, these things, they don't make that much sense or don't make sense at all. But still, they're usually interesting. But if I chose the single talk about functional programming, this will be this Simple Made Easy. It's also very interesting to look at functional programming languages and at their standard libraries, like Clojure and Haskell and ML, different sorts of ML. So these are my sources.
Yeah, I'll definitely repeat the suggestion for Simple Made Easy. I think it's a great talk. I watch it every once in a while, honestly. It's a little shameful, but it's a great talk. Rich Hickey is a great speaker, or he's a very opinionated speaker, and he distills his ideas very well. Whether you agree with him or not, up to you. But Simple Made Easy is certainly worth reading. I would also like to repeat, I would say language tutorials. I would say that in the last few years, there's been a good surge to increase the friendliness of languages, especially in the functional space. And so, those things like learn you a Haskell, there's probably learn you an Erlang or something. I would generally encourage anyone who's interested in programming to gain a little bit of exposure to a lot of languages. And this really helps you to understand much more about your own language. Just how when you learn a second natural language, like if you speak English and you learn French, it teaches you a lot more about the structure of language. So you're not necessarily learning these languages to use them, but it's nice to learn Go and see how that affects how you might use Tornado or async IO inside of Python. Actually, in my most recent project, I was using concurrent programming a lot. I sort of settled on Tornado. And before that, I read lots of talks on Go, or I listened to lots of talks on Go. I read all of the Clojure core async documentation. I read the async IO documentation. And really, by exposing yourself to a broad set of ideas from a broad community, you really become, I think, a much more well-informed programmer. So learn functional programming from many different languages, but come back home and write fairly normal Python, just slightly different.
If you are learning languages for concepts, then I think it's better to find the least familiar language and with different paradigm. It's enough to learn like some Lisp and some ML for functional programming, and then you better go with some logical programming, and then something like stack-based, like FOSS. This will benefit you more than learning two ML type languages or two Lisps. This is a bit of a side from functional programming, but more like interlearning concepts.
Yeah, I can definitely agree that learning different languages of the same general family aren't necessarily going to give you any new... They may give you some new ideas, but they're not going to give you any new concepts or drastically improve your worldview when it comes to programming. So, for instance, I've had experience in programming both Ruby and Python, and they're both pretty familiar once you've started to learn one of them, but I've started delving a little bit into the Elixir and Erlang languages, and that's definitely an extreme paradigm shift, so it's not as easy to pick them up because of some of the functional concepts involved.
Yeah, I'm quite excited about Elixir, actually. That's high on my list to find a project to work in.
Yeah, agreed. That and Rust are the two biggest ones on my radar at the moment. So, is there anything that I didn't ask that you guys think that I should have, or anything else that you guys wanted to bring up before we move on?
No, I think we've covered it pretty well.
Okay, great.
Yeah, can add a little point to this discussion about languages.
Sure.
Sometimes, even if you look at language which you immediately understand because it's similar to whatever you know already, it's still beneficial to look through its standard library or some ecosystem or its packaging tools, because this could be different or this could be better. So besides Python, I'm also using Node.js, and I look at their package manager npm and look at how they install libraries and how they handle dependencies. And it has a very significant difference. Like in single process, you can have several copies of the same library of different versions. This makes you go with dependencies entirely other way. You have some new problems, but you have solved some problems that you have in Python. And if you say about Python and Ruby, which are somewhat similar, but you can read this like enumerable class and all its methods, and it is interesting to read at least first time.
So I will actually say one thing. We should probably add a disclaimer that both Alexander and I come from a similar conceptual background. We both largely agree on things. I think if you had another programmer who was, say, more familiar from the Haskell community, they would have very different opinions. So one shouldn't take our words here as being what functional programmers think. There's lots of functional programmers that would disagree with a lot of what we just said. Functional programming is a very broad term. And a Haskell programmer would come onto this show and say a completely different set of very valid points.
I agree. We could have added also some object-oriented advocates, like coming from Java, or at least from Ruby.
Although there are a number of functional aspects to Ruby as well, and a number of people in that community who are embracing some of those functional paradigms, much the same as people in Python are.
Absolutely. Functional programming is becoming much more hip these days.
So for anybody who wants to follow you guys and keep up to date with what you're up to, what would be the best way for them to do that? Alexander, how about you go first?
I think it's Twitter, Hackflow, and I also have a blog which I don't write often, but still it's hackflow.com.
Okay. And Matthew, how about you?
For me, so my professional website is matthewrocklin.com, MattheWrocklin.com. You can go to /blog, and I write fairly regularly there. I just wrote a thing on testing, and there's various links of all the projects I work on. I wrote tools years ago. I and many other people wrote tools years ago, but I work on lots of other projects today. For tools, you go to tools, TOOLZ, .readthedocs.org. I'm also mrocklin at GitHub or Twitter or most things.
Great. So with that, I'll move on to the picks. And my pick today is going to be Datadog. It's a software as a service platform that makes it really easy to get up and going with server metrics and has a number of different integrations for being able to get some pretty detailed information out of a number of services you might be using. So for instance, if you're using Mongo or MySQL or Nginx, you can add those integrations and start getting some pretty fine-grained metrics about how those systems are running. That makes it pretty easy to integrate with a pager service, so things like OpsGenie or VictorOps or PagerDuty, as well as your chat tool that you might be using, for instance, HipChat or Slack. So recently added this into the environment of where I just started working because we were using Xenos, which, well, it's a good tool in its own right, it doesn't seem to handle as well a cloud workload. So Datadog just gave us a really quick and easy way to get some pretty solid metrics up and running and start integrating that with some of the other services that we're using. And with that, I'll pass it to you, Alexander. What do you have for us for picks today?
I'll choose a TV show. It's an Expanse, a sci-fi one, because I love everything about space. And we don't have much TV shows about space nowadays. But this looks good because it's based on a book. It has a solid story. It goes great so far. If you want something more practical, then it could be, I can type in this.
Okay.
Okay, the more practical thing will be the Revolut app. It's an app which sends you a bank card, which works in every country without any fees in bankomats and translates money at the best cost at best rate you can achieve. I've been traveling last month and intend to travel 1 month more, so it's very handy for me.
Yeah, so I've got 3 picks. First is a library that I ran into just last week on a tools issue. It's Riemann, Riemann. This is a Clojure library, so sort of inside the same theme. They've got a really nice stream abstraction, and it's for monitoring distributed systems. If you go to that page, riemann.io, there's a video on the front that I really enjoyed. So if you're done watching this podcast and you're interested in some of these ideas, it's nice seeing some of those ideas in practice in sort of real concrete problems. It's a nice video.
Yeah, that's a project that I've been keeping a close eye on myself with the intent of putting that into the infrastructures that I've worked on. I have not yet had the opportunity to do so. I'll second that recommendation wholeheartedly.
Yeah, I just learned about it last week. I thought it was really cool. The second one, more of a sort of a humanities pick. There's a movie, 5 Dances. I think it's like an independent film. And if you're into dance or sort of human movement, it's really cool. I think in the first 5 minutes, you'll figure out if you love it or hate it. But it's a bunch of dancers. There's a little bit of plot, but it's mostly them in a practice room going around. So I think it's really cool, but again, it's not for everyone. The third pick is actually a little bit self-serving. What I've been working on for the last few months is a project called Distributed, which is a dynamic task scheduler, so something like Make, but for sort of data science analytic operations. And it's on distributed systems using the concurrent futures interface. So if you like concurrent futures, but you want to use a full cluster, check out Distributed. Again, it's sort of new, it's in beta, but I'd love to have some feedback on it, especially from your viewership. So that's it. I was also going to recommend Hi, but we also mentioned that earlier on in the show. So
very cool. Well, thank you both for taking the time out of your day to join us and talk about functional programming and your work on some libraries to make that easier to do in Python.
And thank you for having us. This is really fun.
Yeah.
Thank you too.
All right.
Adios.
Bye.
Bye.